Hi there, how are you?
Hello there. Nice to see you.
Nice to see you as well. Thank you so very much for joining me. It's quite the honor and the privilege to be able to have you on, and I appreciate the ability to meet with you. It means a lot to me, and I hope you're doing well.
Well, it's my pleasure to be here. It's nice to see you. Yep. No, I'm doing fine. Yeah.
Great, great. I had to give you a little background on my podcast. I had started trying to investigate what they deemed the hard problem of consciousness and subjectivity. And throughout that investigation, it has brought me through a lot of different schools of philosophy and mathematics and physics and science, and ultimately led me to your work, and especially the idea of free energy and how it applies potentially to consciousness. And knowing your background in neuroimaging and neuroscience, I wanted to potentially investigate that with you in that frame and begin kind of by asking you throughout your work in neuroimaging and investigation of neuroscience, what definitively, how has that led you to view the mind, the brain, and consciousness as elements definitively, kind of defining those three ideas and how they fit together relationally and what they kind of mean, so to speak.
Well, that's a very broad question.
Yes, sorry about that. I guess I should have framed it a little bit better. I kind of wanted to get a common ground. It's a hard thing to define, that of consciousness, and so usually I find it hard to merge the definitions between the person I'm speaking with on it. And so I kind of wanted to see, with your process of neuroimaging and your investigation in neuroscience, what how you've kind of just viewed them elementary level in their relationship, if they're separate, independent from each other, and so on.
Yeah. No, it's an excellent question, and a particularly pressing question when posed to me, because if I was answering as a doctor, a neuropsychiatrist, and a brain imaging person, then I would be talking about levels of consciousness, and I'd be worrying about consciousness as a a state that would discriminate, say, between being asleep or being um, anesthetized, being alert, being aroused. So that would be sort of one view of consciousness. But I suspect that's not the kind of consciousness that philosophers and people in artificial intelligence would get most excited about. So if we now ask me as a theoretician, then that's a much more vexed question, and I would sort of read consciousness as uh, a term that can refer to a vague concept, and I'm using vague in what I understand to be a philosophically technical way. Um, so then one has to define, the dimensions and the space of that vagueness. Um, I would then appeal to the fundaments of things that could be sentient and ask, at what level would this kind of thing qualify as having some minimal consciousness? And is that sufficient to account for the kind of consciousness that would be the exponenda of things like the hard problem? So it's a good question for me. So it depends upon which kind of consciousness you want to you want to talk about. There is another aspect to consciousness, which is the kind of answer that or aspect that I would answer from the point of view of a statistician. So neither a doctor nor a theoretician, but purely somebody who is in the game of making the most sense of data. And I use those words because, of course, making sense of data is, uh, on one reading, an act that only sentient things can do. And then we get into the jargon of belief updating, the relationship between consciousness and belief updating. And that's really sort of the technical road that one might take to talk about, to understand the mechanics of consciousness or consciousness as a process, and then get into, well, what kinds of systems can do belief updating, and how can they be disambiguated, and what properties must they possess before you call this kind of thing conscious in a meaningful way, in terms of self-consciousness or minimal selfhood or just sentience or adaptivity.
Absolutely. Okay, I understand. Yeah, the framework by which I seem to have come to conceptualize consciousness as I'm referring to it now, the reason that I had kind of wanted to make a distinction between brain, mind, and consciousness, it seems to me that to be a kind of a critical component and distinction to make, because what I've noticed is that as I've investigated this, it seems to me that consciousness as a whole exists as the arena almost by which agents exist within. Information maybe at its core as what it seems to me to become through my investigation, and neuroscience and basically what they have dubbed the easy problem, which I know is probably a misnomer. However, the neural correlates of consciousness, so our behaviors and then the corresponding regions of the brain that are activated when we act in the world, how that interaction generates subjectivity. And what I had come to adopt in my framework was something along the lines of information being the core of consciousness, from the sense that looking into anesthesia overall, really, and the anesthesis of basically the human and then to the single cellular organism, it seems that all of those have a similarity that they can be anesthetized. And that formulated the basis for me to understand, okay, if things down to the prokaryotic unicellular level can be anesthetized, then it kind of implies that consciousness exists even at that level to me. And the commonality that was there between that anesthetization was the deactivation of the mitochondria and the deactivation of the cytoskeletal components that move organisms towards their homeostatic drive, so to speak. And so I found an interesting correlation there between movement and consciousness, and how it's interrupted in a similar uniform manner all the way down to that unicellular organism. And so it seemed to me that if that's the case, then consciousness either has to be accepted as an emergent phenomena that kind of emerged once something separated itself from the environment. And that became a hard thing to accept. And so I began to realize, okay, so that if it's not an emergent phenomena, could it potentially be the context by which we exist within, and what that context may be? And so I kind of was trying to maybe get your opinion on that. First of all, kind of as consciousness being a byproduct of the brain potentially, or is it something that is inherent to all matter, or is it a field? But neuroscientifically, it seems to me that movement and action towards a goal is dependent upon it all the way down to that lowest level of life. And I wanted to kind of ask your opinion on the interaction with the human brain and the central nervous system. Do you see those components as being necessary for consciousness to exist, or do you see consciousness potentially maybe as a circular arena by which agents exist within, so to speak?
Well, I think you've picked up on three cardinal aspects of consciousness, which I would completely subscribe to, and because that's where all the evidence points, not just the neurobiological evidence, but also the sort of the calculus of sentience and sense making. So you brought three very important things to the table. The first was a notion that at some point there has to be some statement about information, and I think that's absolutely crucial. And I would actually take that even further and say that that consciousness is a particular kind, possibly a natural kind of information processing. And just saying that tells you something quite profound, that consciousness may be a process. So before, I was deliberately using the level or the state of consciousness in terms of anesthesia or sleep, but that's a very different way of looking at consciousness from the notion of information, because what you're now talking about is a process of handling information. The second really important thing you brought to the table was the notion of action and movement. So in order to process, you have to move, and you have to sample the world. If you're not that world, if you're somehow meaningfully separated from everything else in the world, then you have to actively sample that world. And I think that's it's a really simple insight that that things that don't move are generally not conscious. It's so true, and yet there has to be some sort of explanation for that, and I think there is a deep explanation for that. It's also very consistent with the sort of the 4E's turn, the paradigm shift at the beginning of the century, in terms of being situated, being inactive, embedded in an environment. And I use the words situated, even though it's not part of the 4E's, just to lend license to your use of the word consciousness as providing a context. And I'm sure consciousness is not just a context, but certainly it is contextualized and situated. And it's contextualized and situated in the sense, or it is a property, a property of processes that things possess when they are contextualized and when they're situated, and they have to move. So it's an interesting game to think about something that never moved. Could it ever be conscious? I don't know, but I certainly know you'd never be able to infer or assert that it was consciousness, because there will be no way of knowing what's going on the inside. So I think that's absolutely fundamental. The other nice thing that you, from the point of view of a biophysicist, that you mentioned was this common denominator of energy. You mentioned mitochondria, of the thermodynamics, and it may seem odd, but there is a lawful relationship between things that have processes and have dynamics that entail energy exchange, namely thermodynamics, and information processing. And in fact, you can go to the literature, you probably know this already, but things like Landauer's principle, more recently, the Jawlensky equality, that provide a formal, fairly simple and fundamental physical link between the amount of belief updating or the amount of information that you are either destroying or creating, and the amount of thermodynamic energy that is required to do that. So if you are committed to the notion that to be conscious means that you actively process information, then you are also saying there has to be some thermodynamic correlate of that, and there has to be a biophysical machinery that supports that kind of information processing. So I think on all three counts, where you've ended up is, from my perspective, exactly right.
Well, that's nice to hear. I find it intriguing, the idea of thermodynamics and its interplay with biological life versus inorganic life or inorganic existence. And that's kind of what the crux of my inquiry began at, was where does that split between non-living and living, where does consciousness arise on that split, and how does it arise? Because it seems kind of counterintuitive that biological life almost engages in this fight against entropy, as I know a lot of your work kind of indicates too, is that there is that intriguing persistence against the natural tendency to chaos that we can assemble and kind of sort of self-organize against that entropy, and over time develop higher levels of complexity, whether I suppose through natural selection. And that kind of is unique to biological life, and where biological life separated itself by forming a membrane or a Murkoff blanket, as I've heard you refer to before, is very intriguing. Is that Murkoff blanket that is the cellular membrane all the way down to the prokaryotic level. When that occurs, you have metabolizing of nutrients and things of that nature, interaction with the environment in such a way. And once we get to the human nervous system, it seems to me, and evolution took a different route of selection almost. And it wasn't just this homeostatic drives toward food and reproduction that we intend to engage in. We actively mediate between homeostasis and meaning, and a way sometimes by which we can sacrifice our homeostatic desires to instead pursue something that would be counterintuitive to survival almost in a certain extent. And I kind of find it neat, and also, and basically segueing that into what kind of what your opinion and take is on the nervous system's role, and how you see it as evolutionarily, why it would have arisen, or its purpose to have arisen, if it mediates between our homeostatic desires and that of which we seem meaningful, and how you see the nervous system in relation to that.
Right, I think you've just answered your own question. So you've certainly given me all the ingredients that would be necessary to answer that. Just to pick up on a couple of points before we forget them, this notion of sort of, at what point do you have this split between sort of, unconscious, pre-conscious, and conscious things? I think that's a really important question that needs answering, and I think the answer does lie exactly along the lines of the dimension that you're talking about, and in this instance, you're bringing to the table a continuum of different kinds of things that have emerged phylogenetically through evolution. What you've also done is mention this very key aspect of how do I disambiguate myself from the environment? How do I self-organize in a way that I can be separated from my environment, and I don't dissipate into my environment, I don't succumb to the second law of thermodynamics, decay and literally die as I diffuse, all the good D words. All of these are statements of phenomena that inherit from the second law of thermodynamics. So that entropic resistance to entropy simply is keeping myself bounded within my Markov blanket, building my blanket, maintaining my blanket in a autopoietic self-assembly sense. And that costs energy. It literally costs thermodynamic free energy. And from the point of view of the free energy principle, it can be described as a process of minimizing what's called variational free energy, which is the information theoretic side of the equation of information. So with that picture in mind, then what you're asking is, as evolution progresses and we get this complexification and deeper, more complex structures where we get boundaries within boundaries within boundaries, or we get lots of little bounded cells now creating a super cell, or the super boundary, and we have this self-organization that now entails ensembles of separable things. So there are organelles, mitochondria within cells, there are cells within organs, there are organs within phenotypes, there are phenotypes within species, there are species within biospheres, and at every level you have to ask yourself and marvel, how on earth do all these things self-organize and preserve themselves, and why don't they just dissipate into an idealized gas? So that's that is a fundamental question. You're framing it in a way which is enticing for me to answer from the point of view of physiology and adaptive fitness. And why would evolution exert some positive selective pressure on systems like the brain that on the surface seem to wander away from keeping our essential variables within a domain, that wander away from homeostasis? And I think the answer to that is the answer that comes back to this sort of, at what point do we acquire the properties of things that could be conscious? So simple homeostatic things, say literally a thermostat, or very simple single-celled organisms, or perhaps even macromolecules. I would suggest that they don't possess the kind of consciousness that a philosopher will be interested in. But at some point, they get increasingly complicated, and acquire properties that a philosopher might start to get interested in. So now the answer, we have to address, why do things get more complicated? I can't really answer that. There are people out there who are working on this. People like Jeremy England and Kate Jeffries and her colleagues. There are lots of people who are trying to tackle that issue from the point of view of thermodynamics and to a certain extent information theory. I'm going to take a slightly simpler view, which is that which inherits from a free energy principle, and not to worry about why these things emerge, but simply, if they are part of our universe, what properties must they possess? And that property, if it has a boundary that is maintained over time, then it must therefore minimize its variational free energy. And what does that mean? Well, it simply means it's trying to maximize statistically what's called the marginal likelihood, the likelihood of those states of being or configurations of usually the Markov blanket itself. Why am I introducing that? Well, in one sense, this basic principle of existence in virtue of possessing a boundary, something that individuates you from the soup that could be that you could be. One way of reading that is, if that is a fundamental principle, then it should be evident at all spatial-temporal scales, and indeed it should be evident in the absence of any space-time. It should be something quite fundamental. But if we just stick to a classical interpretation that would be apt to talk about natural selection, what we are talking about, we should see the same process emerge during natural selection. So what would that process look like teleologically? Well, any system or anything that reconfigures itself over evolutionary time to minimize its variation of free energy or maximize its marginal likelihood will look as if it's trying to maximize its adaptive fitness. If you are a biologist, if you're a statistician, there's a very different way of reading that, because you can read the marginal likelihood, which is just simply the probability of this set of states on my Markov blanket, on my boundary, say sensory data, for example. The probability of those states, those sensory data, given the presence of a Markov blanket, given the presence, say, of a phenotype or a cell or a person. But as a statistician, I can actually switch out that Markov blanket for a model, a statistical model. And now what I can say is, well, evolution or any process that progressively minimizes free energy or progressively maximizes Bayesian, the marginal likelihood, also known as Bayesian model evidence, is essentially selecting those Markov blankets and their internal structures that can be read as a better fit or model of their environment. So that would be the statistician's reading of marginal likelihood, which would be Bayesian model evidence, or the evidence for a particular model, where now we are reading the phenotype as the model of its environment. So in the spirit of things like the good regulator theorem, each phenotype, each individual, each system just is a model of the environment in which it has to operate and actively do its information processing. So that view means that there will be a progressive, if you like, improvement in the model. The improvement will look as if evolution is selecting the best phenotypes or models that can endure in that environment and in that eco niche. So you can also read this sort of Bayesian model evidence or marginal likelihood as adaptive fitness, tautologically so. And it looks as if evolution is a statistician who's doing this Bayesian model selection, or this sort of selecting the right models, where I am a model, and evolution has selected me because I'm a good fit, I'm a good model of my environment. And if we notice that if this environment is populated or constituted by lots of very complicated creatures like me, my environment is getting progressively more complicated. Therefore, if I'm the best kind of model for my environment, my model is going to get progressively more complicated. And then you can see why our brains, certainly the brains of sort of social creatures, are going to be necessarily much more complicated, much more expressive, to use a phrase from machine learning, than they would otherwise be. So in statistics, the model is called a generative model because it's sort of generating the kind of data that this model would expect to encounter, and you can get into sort of predictive coding stories. I don't think we need to for this discussion there. And this generative model is getting more complicated. So how does that help explain the departure from simple homeostasis? I think quite simply by appeal to the notion of something called allostasis. So what I'm doing here is coming back to your original notion of, at what point can we put these splits, or from my point of view, this range of vaguely increasing consciousness. I would say that that's an attribute of the generative models, the organization of the phenotypes that, as they evolve, both in evolutionary time but also in developmental time, ontologically, there is an increasing goodness of fit to the environment as scored by variational free energy, Bayesian model evidence, marginal likelihood, adaptive fitness. They're all the same thing mathematically. So what kinds of different models might emerge? We can start with very simple models that do reflexes. Notice that a reflex entails action, which is why I was so anxious to highlight your observation that things have to move. Simple reflexes like single-celled organisms doing chemotaxis, sort of biological thermostats basically that just sit around their fixed points. And then we can have more expressive generative models that now come to cover and be able to generate predictions about the consequence of an action. And they have a very special characteristic in the sense that because the consequence of action has not yet occurred, then you effectively have a generative model of the future. So put very, very simply, in the same spirit as your really simple but profound observation, things move, or if they don't move, they can't be conscious. I'm going to make another really simple, but I think quite profound observation. There are certain kinds of consciousness that can only be possessed by things that can plan. So what does it mean to plan? Well, to plan means you have to have an idea of the future. You just have to have a phenotype that now is a model of your world that entertains the consequences of your action. And once you can plan, then I think you can move away from homeostasis. So there are lots of lovely examples of this, but all that we're saying really, we're using allostasis in this instance in the sense that if I felt very, very cold, I could do one of two things. I could either evoke my homeostatic responses and respond immediately and start shivering and raise my hairs, pile erection, or I could go inside and light a fire or turn the radiator on. Now, the second requires some planning. I have to think about what would happen if I went indoors and sought out some heat. And if I plan and realize that pursuing that course of action now takes the pressure off the homeostatic response, then I can plan to position myself so I never need to really engage homeostatic reflexes. So we've not, if you like, eliminated homeostasis. What we've done is, again, to use your word, this contextual word, we've actively changed the context so that homeostasis it has a really easy job, and that's many people's interpretation of allostasis. It's just a more deliberative, temporally extended, deeper response to putative or potential violations of your homeostatic set points. So I would say that now, if we're now dealing with evolved, deep phenotypes or things with a deep generative model that is deep in the sense it has a temporal depth. There's a non-trivial temporal horizon to the modeling of the consequences of action. I think we're now moving further towards the threshold that you might say, well, there is some minimal consciousness here in the sense that this thing is actually planning. So you probably wouldn't find that in bacteria or viruses. And you start to ask, well, would an insect, could you say an insect's planning? Did it actually think about the future and decide to do this or that? Or was this a reflex? So that would be the first step in your game of splitting consciousness into a set of different kinds of consciousness. Does that make sense?
Absolutely. No, it does. It makes a lot of sense to me, and it kind of falls in line with how I've begun to think about it. And when we talk about the Murkoff blanket, I feel this intuitive sense that there's an ultimate Murkoff blanket that has to surround the entirety of existence, and this embodiment of context in itself reminds me, I guess, like I was using this analogy recently in another discussion, and maybe it'll resonate a little bit with what you had just said. And it was the utilization of a motherboard that contains transistors within it. And by the nature of being a transistor on a motherboard, it has a sense of, it has to be a 1 or a 0, a state of on or off. And by simply being a component of that motherboard and being a transistor, it has to embody a 1 or a 0 by the nature of being a component of a larger system that's symbiotic within its own self. And that, to me, is also, like you had mentioned, machine learning, this idea of DNA and the idea that we can have A, T, C, and G is almost like a machine code language that is then taken from a genomic template, like the human genome, and produces this phenotypical expression. And it does so with some type of intelligence within itself, within the environment. And that process of genotype to phenotype, and the genotype being that template by which we generate our phenotype, it seems almost to me like sensory data that we bring into ourselves needs that template by which to be interpreted as well. And so it seems like the hardware, the DNA, is coding for the brain, and the brain kind of acts, since the brain is existent within a larger Murkoff blanket, by nature of that, it's conscious, essentially, because it's embodying that ultimate Murkoff blanket that we exist within. And it seems to me like that there needs to be a software component almost associated with the interpretation of sensory data, just as much as there needs to be something by which the machine code of DNA is then turned into proteins that we can see, like crystallography, and you see the intricate nature of proteins in a 3-dimensional form that's encoded from information, 2D. I mean, information, essentially, if you want to look at it like that, in A, T, C, and G, and those codons and those base pairs, it's to me, it seems intuitive that, okay, they're embodying the context, and by which the context we exist within is in itself implying that whatever exists within it would be conscious to a certain extent. And at that point, what is that? What's the template for the sensory data that's being taken in? And is that consciousness taking that sensory data and converting that into something usable and meaningful?
Yeah, no, absolutely. I mean, that template, I think, and that taking or meaning making or sense making of data is exactly what I was mathematically implying by the generative model being the template, and the use of that model to explain. You can think of it as, like a mathematical structure that's like a hypothesis, that is there to make sense of data by selecting the best explanation for that data. So technically, that belief, Bayesian belief updating process that we were talking about before, just is, the sense making or making meaning out of the data under a particular generative model or template that has to come from somewhere, and as you've rightly pointed out, it has to come from the genotype and be epigenetically specified. So we've got information at every level here. We've got the information about the template, and then template has to do its job by information processing, by the sense making, and also just to come back to where you started, in fact, which is sort of information has to be, everything has to be underwritten by information, and I would say information processing at many different scales. Notice all your analogies, motherboards, the information in DNA. It's all at some point about information processing and the passage of information from one moment to the next, or one generation to the next. So I think that's absolutely crucial, and certainly when you want to put a calculus on this or put some mathematics on this, it is information theory that you use. And one example of that is the free energy principle, or statistical readings of the free energy principle, such as Bayesian belief updating. So that's absolutely consistent, I think, with the physics of sentience that you get from the free energy principle. The other thing that you were talking about is this sort of and everything being enshrouded by a sort of an even larger Markov blanket that contains all the Markov blankets that could be the single transistor. I think that's absolutely right, and that's very important to remember that there is a hierarchical structure in play here that is effectively scale free, in the sense that the same rules apply to every space-time scale. So we're not talking about one Markov blanket. I have a Markov blanket of, I don't quite know where it is, but I'm sure I must have one because I exist. But every organ in my body will have a Markov blanket. Every cell within those organs will have a Markov blanket. And of course, my cultural and physical eco-niche is another Markov blanket. It exists. So at every level, you're absolutely right, there are Markov blankets within Markov blankets, and so on ad infinitum, all the way out and all the way down at different scales. So I think that's a very important observation, and does beg deep questions about the coupling between self-organization and blanket building and belief updating at one scale to the scale below. And I think this sort of focus on DNA is a very beautiful example of that, because you could look at natural selection as Bayesian model selection, the natural selection doing its belief updating by refreshing and revising and optimizing more adaptive generative models or phenotypes. And this is all about passing information transgenerationally encoded by DNA. But at the faster, smaller scale of an individual phenotype, then exactly the same maths should, in principle, be playing out. And you have to, and from the point of view of that faster scale of sense making and sentience, we're talking about the information processing that you and I are doing at the moment. We're making the most sense of our exchange, all our extrasensitive and other sensory inputs. So how are the two linked? And I think that's a really fascinating question. I would say that the epigenetic specification of the generative model, which you then use to do the fast information processing, the fast sense making, is just the DNA. So that what the DNA provides is a scaffold, or the information about the structure and the form of your generative model, that you then deploy and use at a much faster time scale for an active engagement with the world.
Absolutely, yeah. That makes sense to me. Especially, I like the conceptualized idea, the active inference. Almost, if I go back to that motherboard machine code analogy, whenever you have computer programming and you have a compiler or a translator that's taking that like program that's written by a human and taking it and putting it into binary machine code, active inference in this situation in relation to that same analogy almost seems like it could be the operating system by which this is happening. If I'm trying to stick with this analogy, it may not merge too seamlessly with it, but it seems to be that kind of case. And I want to quickly kind of go back to how you mentioned hierarchy, the hierarchy of consciousness. And originally you had said that if you were speaking on consciousness as a philosopher, you would talk about it in terms of levels of consciousness and things of that nature. And then you were talking about hierarchies. I think it seems to be, I wanted to ask you, do you think the hierarchy that we see in the cerebral cortex, as it's gotten thicker over time, it could be correlated to these levels of consciousness that we see where consciousness becomes self-referential and we reference self to other? We see that probably only within nervous systems, things that can re-represent and create implicit representations of the explicit. When that happens with the CNS and the evolution of it, that's a hierarchy of consciousness and in a certain type of way. And so I wanted to ask you kind of on the cortical evolution, and what's your thoughts on the cortical evolution as it pertains to the levels of consciousness that you were speaking on just a moment ago?
Right. Well, my thoughts are exactly as you've just described. So, part of this complexification that you see both on an evolutionary scale and an ontological or developmental scale is just to get these hierarchical structures in play. So from the point of view of the brain, what does that mean? Well, it means that we live in a world that has a separation of temporal scales and has a very deep causal structure. There are content and context at every scale, where usually the content of things that are happening, say for example, the words that I am speaking at the moment has a context, the context of our exchange, where I am, that changes very, very slowly. I'm in the same room that I was half an hour ago. So these are fundamental observations about the nature of the world to be modeled, the nature of the niche, the eco niche, for which I must be a good model. And if I'm a good model of this deeply structured world, then that will be installed in the structure of my motherboard. That will be installed in my brain. So my motherboard will also have this deep hierarchical structure that incidentally only acquires the structure through the induction of Markov blankets that form the hierarchy. So a hierarchy is a separation into different levels. So again, we come back to this blankets within blankets and this separation individuation. So this is exactly what we see in neurobiology, that the more expressive models of higher life forms do indeed have this deep structure, this hierarchical structure, and probably the human brain is probably one of the best examples of this. So you have a cortical hierarchy, and you can see that if you did neuroanatomy, you'd start, say, in the visual hierarchy, sort of starting at the back of the brain and then coming forward. You start with V1, then you have V2, then V3, then V4, V5, and so on. So literally, you can see anatomically the different levels of the brain's hierarchy, and just pursuing that notion of hierarchical depth going hand in hand with an increase in the space and time scales of the things that you are modeling. As you get deeper into the hierarchy, literally deeper into your brain, away from the sensory interface. So for the motherboard, it would be the API, or what you're putting in and taking out. So right in the middle of the motherboard, the deepest kind of bit switching and processing and message passing will be concerned with inferring the right context. It will be concerned with finding the best context that provides the best explanation for everything else that's fluctuating much more quickly at lower levels of the hierarchy. And in one sense, if there's one context that is pervasive throughout my life, it's the fact that I am me. So this now becomes a central, not necessary, but for generative models that have it, it's a very plausible hypothesis that contextualizes and enables the right message passing at lower levels of the hierarchy. So I think you're absolutely right that you have to have the hierarchical depth before you can even have the kind of hypothesis, the kind of explanation, the kind of sense making that has that would be appropriate to explain selfhood, in the sense that the self is an enduring context. It's conserved over long periods of time, and as such, it then necessitates a very deep generative model, would necessitate the kinds of brains that have anatomically and physiologically this sort of deep physiological structure, which means that there must be other brains that don't, which means that there must be lots of brains out there that don't have that sufficient depth, and they can't sort of accumulate information or assimilate information over extremely long periods of time and then say, yes, this context, say selfhood, I did that, or it is me experiencing that. This would never be necessary because they're not accumulating over the right time scale. And you might imagine, again, things like single-celled organisms, or possibly, very simple life forms, right down to viruses, just don't have this hierarchical structure that would ever permit them to have these kinds of this kind of sentience, this kind of sense making. Whereas, when I think you get to the level of pets, for example, you might start to argue that there could be a minimal selfhood, because the brains of some animals do certainly have a hierarchical structure, and it now becomes an interesting question. At what point would you want to have a philosophical debate with that kind of animal as opposed to a philosopher?
Absolutely, yeah, I see that as intriguing as well, because even when you're talking about pets, you're looking at an organism that has a nervous system, has a brain, has the ability at that point to re-represent and image with images. Maybe we don't. I guess we wouldn't know for sure, like you just said. And something that comes to mind just as you talk about that is when you say, yeah, there's lower level Markov blankets, there's lower level intelligences. Something I find intriguing is split brain research in regard to the type of cut that is made when a brain is split through the corpus callosum. It's a vertical separation, a bilateral separation, and I think there's something noteworthy about that has to be a vertical bilateral separation between the two hemispheres. Rather, if we were to cut it in a different fashion, it would make the organism non-functional. And so what is kept intact in that process is the hindbrain, is the limbic system. That brain stem is still there. So when you make that vertical separated cut in the brain, you're still maintaining that ultimate part of the brain that can desire homeostasis, that maybe potentially is what lower level organisms possess at the origin of the nervous system. Is they maintain the brain stem, and they maintain the more fundamental elements that are more primitive, evolutionarily more primitive to our development. And so I think split brain research is interesting because it does preserve the limbic system and the more primitive aspects of that when you cut it bilaterally. And so maybe that also, would you kind of see that as a potential for justifying these higher levels of selfhood and consciousness, that, okay, we cutting the brain in half through the middle preserves that portion of the more primitive brain, which could potentially be representative of these higher and lower levels of intelligence and selfhood and consciousness overall.
Yes, no, it's a fascinating observation, and it speaks to this notion that the anatomy, the structure of the brain, has to have installed in it the causal structure of me in a world. And I think what you're saying is that there are certain aspects of that structure that if I destroy in the wrong kind of way, I'm going to no longer be a good model of my world. But there are other aspects that I can disconnect or cut the wires between with actually minimal impact on the quality of my models. That's a really intriguing observation, and I'm sure you're absolutely right. The transection of the corpus callosum doesn't speak to, it doesn't, if you like, disconnect the hierarchical message passing between different levels, because at some level down the hierarchy, there will be a meeting of minds and there will be a preservation of the same structures. I also have to point out that, of course, even in completely brain preparations, both sides of those brains, even at the higher levels that have been separated, they're actually still privy to the same information. So there's something fundamentally different from the point of view of information processing between two people with half a brain each and one person with a split brain. The one person with a split brain is one united by the fact they're trying to explain the same data. They're making the sense of the same data. So that actually introduces conditional dependencies, even if there's no direct influence and there's a Markov blanket between the right hemisphere and the left hemisphere, at least at the cortical level. But it does raise really interesting questions about other kinds of splits in the brain, because there are other natural splits. So I'll just tell you my favorite example, just because I'd like to come back to the split brain in a second. So my favorite example of this was championed by people like Leslie Angelider and her colleagues, which is the distinction between those parts of the brain that are responsible for information processing in about where things are. And that's usually associated with a dorsal stream that sort of comes from the visual cortex and then goes up around the top of my head. And another ventral stream, which is much deeper and goes to the paralimbic and the hippocampal regions, which is concerned with what things are. So, what is this? It's a hand. Where is it? Oh, it's over there. Those two different attributes are processed in very, very different parts of the brain, almost to the extent you could conceive of it as a split between these two streams. So why might that occur under this view of the brain as an evolved model of its lived world? Well, it's a very simple example of how statistical structure in the world gets written into or installed into neuroanatomy of this splitting, or mathematically what we call factorization form, simply because knowing where something is doesn't tell me what it is. And knowing what something is doesn't tell me where it is, generally speaking. So I can say it's a pen, but where is the pen? It's over there. If it's over there, what is it? Well, unless you tell me, I don't know. It could be a pen. So just the very fact that we live in a universe that have objects that can be moved means that there now becomes a statistical or a conditional independence between whatness and whereness. And that's now transcribed or installed into our anatomy. So if you take that notion forward and say, okay, why on earth do we have two hemispheres? What does that tell you? Well, it tells me immediately, for example, if you gave me your brain and I didn't know anything about your phenotype or the world in which you lived, I would say immediately, I bet this phenotype's got a symmetrical body. I bet they've got two of everything, simply because much of our lived world is, of course, constituted by our body and the way that we move and deploy our body and palpate the things that are not part of our body. But much of the sort of sense making and the sentient behavior is really about modeling our own body, which brings us, of course, back to something you slipped in earlier on about self-modeling and selfhood. So self-referencing, you're talking about representing oneself, and that's what I think is a key aspect of consciousness. But from a very simple point of view, the very fact that you can do split brain experiments presupposes you've got a brain that actually has this right-left symmetry. Why? The liver doesn't, because of course the liver has to predict and manage blood, and blood doesn't have this physical symmetry, but the brain does. So I think it's a lovely example of being able to read from both natural selection and your neurodevelopment, the history and the structure of the world that this thing grew up in, and has accumulated the information within its structure, this structural information.
Yeah, no, I think that's wonderful. That's actually just beautifully stated, really. And symmetry at when we talk about physics is all the way down to that level. Even, quantum level, with there's supersymmetry, there's a quantum entanglement. There's something about this symmetrical arrangement of the universe. And not that I'm trying to extrapolate quantum to classical in this scenario specifically. However, the bilateral symmetry in humans and the brain is, like you had said, intriguing. And like you said, written into is something, that phrase you use kind of sticks with me in another analogy that I like to employ when I think about this, is like a blueprint from an architect, but not just a static blueprint that's produced by an architect, but more so the conversion of that blueprint by a separate party into a building. And so the blueprint comes from the architect, handed down to the contractor, who then employs multiple subcontractors to construct the building. Well, at the end of that process, there's a whole new set of drawings that has to be revised and produced, record drawings of all the changes that were made to that building that occurred over time when the building was being constructed. And so I see a lot of times this analogy of the blueprint used sometimes as a template, just like we were talking about earlier. However, it's too static for me to be, it's not dynamic enough to encapsulate all of the components necessary to satisfy my philosophical inquiries into will and choice and things of those nature. However, whenever you think about it, the dynamism that exists between the blueprint, the contractor, to the final product, and then it goes back to the architect to be revised and produced as a record set of as-built changes. And so to me, it's interesting that that exists, that phenomena exists kind of within our own sense of self. We have DNA, of course, and epigenetically we understand now, it seems, that these can be turned on and turned off. It's not all junk DNA, but it's genes that might not necessarily activate for that time. And so your environment may not necessitate you to activate those genes. Well, just like a blueprint, you're going to make changes to it over time and reproduce it in comparison to the template originally set. And that's how I, to kind of move into this realm of free will, which is a broad topic. That's how I usually describe, or in my head, conceptualize free will, as if there's this template by which we have to operate, which is our homeostatic drives, which must be satisfied. That is a template by which life is dependent upon. However, how we go about getting those drives satisfied when we have a nervous system is flexible, and that flexibility still operates within that parameter. And so you're looking at another Murkoff blanket almost, so to speak. And so I just find that interesting analogy to me, and I wanted to get your opinion on that analogy in particular.
Yeah, well, I would read both the template and the blueprint as metaphors for exactly this generative model. And I think they're very comfortable metaphors in many different senses. So indeed, when you first started talking about the motherboard, and then you went on to information encoded in DNA, I thought to myself, yes, of course, somebody has to have the blueprint for the motherboard before that can be made. And it was that kind of information, which is distinct from the transistor being on or off, or gating or not, which is much another kind of fast information, which would be the more information processing. But the context also has to be informationally endowed through the template and the blueprint. So I think that that's a nice metaphor. The other, for me, the metaphor of a blueprint as a generative model, I think can be comfortably developed along the following lines: that what you really want is a living blueprint. You want the adaptivity in play, so that you get the little nuances and the sort of the way the builders actually interpret the architect's plans under these constraints, or the changes that are made when you actually have to come and interface or exchange with in this instance, the world of construction. So that for me would be really the revising of the generative model when you're exposed to experience and when you're developing and growing and learning. And the biological mechanism that endows the blueprint with this adaptivity would be, for me, experience-dependent plasticity that underwrites learning. So, if we go back to the motherboard as a metaphor for the brain, and the flickering and the passage of electrical messages and switches of various gates and the switching by the transistors would correspond to online activity as I sense, make, and as I behave and act and pursue my homeostatic imperatives, or preempt them allostatically. That would be the fastest scale. But then, and we've already spoken about the slowest scale of belief updating, or in a theological sense, optimizing in relation to the evidence, which would be getting the blueprint for the motherboard right, and we'd do that as very, very slow. The factory finds that these kinds of motherboards are selling better, and they send it back to the architect and say, we want more of this kind of motherboard, thank you, and less of that one. And then slowly the very structure of the motherboard, its size and number of sort of compartments, starts to evolve very, very slowly as the market turns over and taste change. But there's a middle ground, which I think is what you're talking about. There's a middle ground in the neurobiology. This would be the middle ground between fast inference, fast belief updating in the moment, the sense making that relies upon message passing and neuronal activity in the brain, being the very fastest kind of belief updating or information processing, and the very, very slow transgenerational lifetime switching of the basic genetic and epigenetic codes that tell you how many hierarchical levels you've got, and the symmetry of your brain, for example. There's an intermediate one, and that's learning, either at a developmental time scale over the weeks and months and years after we're born, or indeed experience-dependent learning as we come to assimilate rules and contingencies over long periods of time, like learning to ride a bike, or just becoming familiar with living in this city, or indeed for this period of time, under these weather conditions. So this is sort of more this context learning, and the way that intermediate time scale works is by basically switching in and out connections in the brain. So so this would be synaptic plasticity or experience-dependent plasticity. It is exactly the level of optimization and information processing or belief updating that characterizes machine learning. It's getting the connection weights right in deep learning, for example. So deep learning is just a statement: you've got a neural network, has a deep hierarchical structure, and then you optimize slowly the connection strengths and the weights as you expose it to lots and lots of data over a long period of time. So I think learning and experience-dependent plasticity, as mediated by in machine learning, things like long short-term memory, in neurobiology, this would be neuronal plasticity or synaptic experience-dependent plasticity. Both of these are basically the same process that would be the mechanism that would make your blueprint adaptive and dynamic. And once it's adapted and accumulated all the dynamics of that lived life, you then pass it back to the architect, evolution, to say, this is what this blueprint has turned into. Now revise, summarize, write down the new code, and then carry on.
I see. Yeah, that's beautifully said. Well expressed too. That metaphor I had kind of just thought of in my head, and you took it there, and I think into a very poetic description, and I'm able to even further that metaphor myself now, by the nature of what you had just explained, and it helps me even understand it better, and I see it the same way. I mean, as you just described, and I as you mentioned riding a bike in there, just to speak on that for a second, it's interesting, the idea and the possible beginnings of a nervous system. I had spoken with another person in a dialogue similar to this about muscularity and its interrelationship with the nervous system, and how his proposition was potentially that they co-evolve, muscularity and the nervous system kind of co-evolved, and potentially that would make sense why riding a bike, that kind of memory, that kind of learning is encoded in the muscles. Well, it's kind of intriguing to think of the nervous system and muscles. The nervous system and muscles are exchanging sodium and potassium ion channels, and of course contracting due to the electrical impulses of the nervous system, and the coevolution of muscularity and the circuitry of the nervous system would kind of be an interesting way to apply that to riding a bike, and would kind of explain that type of learning to me in a certain way.
Yeah, absolutely, and that I think speaks very strongly to the enactive and the embodied sort of 4E perspective, that you've got this co-evolution, this co-optimization. Markov blankets aren't specific to the brain. The brain has no privileged definitional ownership of Markov blankets. Muscles are equally important. They can have their own Markov blankets, and they have to talk to brain Markov blankets and vice versa. So I think that sort of, again, situated, embodied aspect is vitally important to see all of these, all this kind of information processing unfold at the same time in the way that you just expressed. You could even take that that sort of co-evolution perspective in terms of the embodiment. I mean, you could even say I'm not sure the person you were talking to was a radical inactivist, but there are people out there who would say you don't even need the brain to do this to do this properly. But not going down that avenue of conversation, but just coming back to this notion of the circular causality and the co-evolution, the mutual sympathy between the modeler and what is being modeled, noticing that you can switch the two around. So the brain is trying to model the muscles, and the muscles are trying to model the neural impulses from the brain and respond adaptively and grow in the right kind of way, while at the same time the brain is actually engaging these muscles in this coordinated pattern that enables you to ride a bike. So there's a circular causality that goes on there, and it must be that kind of circular causality must be very important when I'm first born into a world and I just have to work out how this universe works. So, I don't even know that I am a thing. I don't even know that mum's a thing at this stage. And one can imagine this sort of co-evolution of, in the sense of things like attachment theory, or more simply, nurturing and of a mother, the nurturing behavior that she supplies to her infant is going to be as foundational in terms of this dynamic blueprint, the learning part of getting the model right to this kind of universe that I've never experienced before, is as important as the adaptive brain of the child, the infant, the neonate, trying to make sense of all this. I'm sort of focusing on that because I think that may be the secret of deep generative models, deep dynamic blueprints that have this sufficient depth to include selfhood. Because if it's a question of working out how my universe works so that I can model it appropriately and act upon it, then I've first of all got to realize that mum is not part of me. Mum is somehow independent and has intentions, and sometimes responds to me crying and sometimes doesn't, and that has to be explained. And then I have to work out, well, that's interesting. So sometimes mum is part of me and sometimes she's not. Perhaps she is a thing. Perhaps she has her own intentions. Perhaps she's a creature. And then you can say, well, perhaps I'm a creature. Perhaps that explains, why. And then you can see how this dynamic blueprint, this deep generative model can slowly build hypotheses that entertain notions of selfhood that are necessary simply because I live in a universe that is occupied by other things like me, namely mum. And if I didn't live in that universe, I wouldn't need selfhood. But because I do, because very much like the muscle provides the context for the brain to learn about how muscles work whilst riding a bike, it may well be that our families, our culture, and our mothers, certainly very, very early on, provide an essential context that determines what is learned, even if I'm doing the learning. So I think it's a really, that example of the muscle and the brain is quite a potent example that actually applies, I think, to some of the fundamental problems facing us when we're first introduced into a world.
Wow, yeah, that's once again poetic comparison of that to. I had never thought of it in that way, relating that coevolutionary aspect of any type of coevolution. I've always understood that there was a coevolution of multiple different species. Obviously, there's a symbioticness between photosynthesis and respiration in a human. Obviously, that exists, but that's not interspecies. And then we get even further inner self and distinctions between self and other, applying coevolutionarily between mother and child. And that's an intriguing point because infants, at least from what I understand thus far in my research and just my understanding, is that babies are, when they're born, not conceiving yet of self and other. They're not perceiving environment as a separate entity from self, and they haven't yet garnered a theory of mind that has perceived or that has the ability to reference self. And so you're exactly right, I think, within that metaphor. In fact, I think it's very, very picturesque of what I'm thinking in my mind now. And the distinction of self and other and the recognition of that, not only maybe is it influenced too by like you said, by mother, of course, but like you said, I find it interesting, if you don't mind me venturing into this kind of philosophical arena of East and West for a second, but the Eastern philosophical thought is very much more oriented towards the lack of self and the illusory nature of selfhood. Especially in the Vedic practices, Indian practices, those in that area are focused very primarily on oneness and lack of individuality and sovereignty. And the West is individualistic and more so capitalistic in that sense. And culture not only is ultimately too determinant upon how strong of a sense of self we end up developing in response to our relationship to other. And so how we engage in social interactions linguistically, biologically, operationally in the world as an agent. It's interesting to me to think of, as you mentioned, that concept of selfhood developing in the mother and the nurture. It also culturally dependent, maybe so. In the East, it's so much more oneness, and then in the West, it's a little bit more dualistic. It's me against the world almost, and then over here, it's the collective whole trying to operate in unison. And so I think that culture and mother most certainly applies very aptly to the analogy I was generating there with the coevolution of the nervous or muscularity and the nervous system. So I find that quite intriguing. And I think too, to extrapolate, if we don't further, going back to biology, going back to evolution of the nervous system, I find something very intriguing. So when I looked at these anesthesia studies that I was mentioning earlier, there's multiple factors, it seems like, in multicellular and multi-organ system organisms like a human. Whenever you administer anesthesia to a human, there's several things that are occurring that end up resulting in the loss of self-reference, the loss of of referencing the experience to self. Therefore, you're not aware of the experience. You're not just asleep. You can't be awoken by being poked, so you're obviously extracting out that self-reference of experience to memory. So that's interesting in that regard. But what's even more fascinating to me is that the commonality of anesthesis through evolution at the bacteria level, like I had said earlier, is we talked about mitochondria and metabolism and energy, but also there's one other factor that I'd seen in the papers was the cytoskeletal interruption was common. That was one of the two common factors that is all the way up to the multi-organ system organisms like humans that gets interrupted with the anesthesis. So to me, cytoskeletal elements are like microtubules, which are integral to muscles, obviously. And we're talking about coevolution, and then we were talking about multiple brains out there and evolution of brains. Well, something to do with the microtubule and the cytoskeleton is involved with movement, obviously. And to me, as I interpreted Sir Roger Penrose and Stuart Hameroff, the physicist and an anesthesiologist who work in conjunction, they formulated this theory called that they refer to as OR, which I believe is orchestrated reduction. I'm messing that up, and I hate that I am, but it's OR, and the way that they frame consciousness is this mechanism of microtubule interaction. Basically, whenever they administer anesthesia, they looked at it in such detail that it wasn't like consciousness was this ethereal essence that was being extracted from the body during anesthesis. It was more so they looked at it down to the level of the neuron and saw that it was actually the interruption of the pyramidal neurons in the higher levels of the cerebral cortex that were interrupted. And that process in itself differentiates wakefulness, sleep, and anesthesia to me. And so that may be talking about evolution and coevolution of muscles and cytoskeleton. It's interesting to think about potentially even bacteria that move. They move with flagellum, which once again, that's made up of tubulin fibers, tubulin proteins. And that's interrupted at the level of the organism as a human and at that level. And so I'm thinking more now too that there's a coevolution that occurs, that maybe not everything has a brain and a nervous system, but they certainly all have cytoskeletal filaments, and those cytoskeletal filaments are common to muscles, the brain, movement, and ultimately anesthesia. And so I know that's a lot. That was kind of a lot of branching that I just did there with that statement, but I wanted to get your opinion on the cytoskeleton, really, and it's what your thoughts are on it in neuroscience and evolution.
So I think we're coming back to the one of the three fundamentals you introduced at the beginning, which, to show any kind of sentient behavior, even if it's not actually made sense of in terms of I am a self prosecuting the sentient behavior, have to move. And this has to apply at all levels. And what you've just done is described a foundational scale of that movement, the microtubules, or in some formulations say the actin filaments, and all the molecular motors that would drive flagella in single cell organisms or cause our muscles to contract in multicellular. So I think you're again speaking to something quite fundamental, which is the ability to move and to act upon the world. And I would put the observations about microtubules specifically at a specific scale, because that's where they live. So by definition, sort of microtubular explanations for the necessary properties that any conscious artifact must possess. The microtubule argument sort of places it at a particular scale. So the scale of information processing we are talking about now, I think, is intercellular. So the kind of Markov blankets that we are trying to understand are no longer at the spatial scale of muscles and people and babies and mothers. They're now at, how does a cell exert or manifest its sentient behavior in the context of its culture and its community, which are the other cells to which it is connected through external processes. And as soon as you look at it like that, I think both the essence of how cells act on each other becomes sort of essential to the manifestation of sentient behavior at that scale. But you can also read that as essentially the message passing that would be required for the information processing. So at the scale of lots of cells talking to each other, so ensembles of cells. So now we're talking about the transistor on your motherboard that has at least 3 components, in 2 inputs and then a gating input. So now we're talking about little motifs of cells, or at least compartments of a single cell. So the action, the way that those elements of those motifs act upon each other, or cells act upon each other, from the point of view of this information processing that underwrites consciousness of all kinds, you need this kind of activity. And I'm framing it like that because that provides, I think, a relatively straightforward explanation for the universal role of anesthetics. If you switch off the ability of one cell to act upon another, to pass a message, to participate, as you were describing before, in the information processing that is contextualized by the motherboard, you can't have information processing, and therefore you can't have any conscious processing. So I think it's a very simple observation, but also quite profound. You need to let cells and everything within the cell act upon stuff beyond its Markov blanket, else there will be no agency, even at this sort of almost nanoscale and possibly even quantum scale, but certainly at the scale that would be requisite to talk about the way that we are sentient, as macroscopic beings.
Absolutely, I think so. I think that you're correct. Yeah, what I'm talking about there with the cytoskeletal, yes, yeah, it's a fundamental, more elementary. It's ingrained in its scale. Yes, it's scalar. It is very. When you're talking about just cells, then interactions between cells, and even the axon of a neuron. And obviously, structurally, there's multiple types of neurons. So it's not that there's generally this picture I always see on the internet and different places of the neurons all interconnected in this web, and they all look the same. And it seems like this is this stereotypical model of the neuron that everyone has in their mind. And I think maybe it's a little bit deceptive to the idea of the structural differences that really truly exist in neurons. And especially in the axon, when you're looking at the neuron, it's composed of microtubule fibers down the entirety of it, almost like a circuit. It's transmitting that's what's carrying this electrical impulse, so to speak. Maybe. I mean, I'm not in academia nor qualified to make presumptions like that. However, I would say that in my own framing of it, I've come to the conclusion that makes sense. And you mentioned quantum there, like that quantum scale. Well, the other component that I noticed that the gentleman who created that OR theory of consciousness that involved microtubules is integral to that is the idea of quantum interactions within the human brain and within the microtubules themselves. They propose in their hypothesis or theory that essentially tubulin fibers are constantly within a state of superposition, and they interact with something fundamental in the quantum foam of the quantum field that collapses down that state of superposition. Basically, if it's a binary state of 1 and 0, well, it's both at the same time, and something about choice or will or movement collapses down that state of indeterminacy within the microtubule superposition down to 1, or essentially thinking of light collapsing from a wave to a particle, or something becoming manifest into classical from quantum. That process is conducted as proposed by these gentlemen, is that, and my interpretation, if it's correct, is that the process of wave function collapse occurring is fundamental to realizing the classical world from the quantum, and that is mediated through the microtubule and cytoskeletal functions of the brain. I find that interesting. I wanted to ask you kind of what have you, whenever you talk about scale and quantum scale, as a neuroscientist, I find it intriguing as being able to talk with you, which is very nice. And I wanted to take the opportunity to ask you that question. As a neuroscientist, what do you see the quantum element of that being potentially possible in the human brain? Generally, we associate quantum superposition and those kinds of things only occurring at like really rigorously cold or almost absolute zero temperatures. So it's kind of hard for me to extrapolate it past that to the human brain, but I have seen some studies that propose that, or have seen observationally, photosynthetic processes in plants with the photon being in multiple different aspects of the plant leaf at the same time. If that's been observed, if that's been observed, it's been observed at non-absolute zero temperatures, meaning potentially could happen within moist environments as well. I didn't know if you would potentially agree with that, or if you would see that the quantum activity could occur within the brain, and what your opinion on that would be. Sorry.
No problem. Yeah. So I mean, certainly there is activity at a quantum scale in the brain, and certainly conscious processing, I think, would certainly entail that level of description. If you're asking whether superposition, as observed in quantum setups, very small scale setups, or indeed plants, is the answer to consciousness, then the common sense would suggest no, unless you believe plants are conscious. So I think the question then, does this quantum kind of formulation have anything to offer? I think it does, but paradoxically, simply in its scale-free aspect. So if you treat quantum theory as more a theory, a fundamental background-free theory of information, then I think you're in a much stronger position to argue for a quantum formulation of measurement and of inference. And if you can do that, then you're in a very strong position to offer a calculus and an account of information processing. And if you can do that, then I think you've got the right calculus to talk about consciousness. So I say this with caution and undue confidence, simply because I've spent the past few months talking to friends who know about this kind of thing. So as a neuroscientist, no, that's a little bit disingenuous. I did do quantum physics as a physicist when I was at university, but I've forgotten it all. But I've been in conversation with people like Mike Levin and Chris Field and his colleagues. And we've actually just released a paper, which is a quantum formulation of the free energy principle, on which I was a passenger, basically learning a lot. But what I took from that was that the kind of information processing we've been talking about, and we've been talking about a number of different scales, and that's all I mean by scale free. I mean that the same rules apply, whether we're talking about a transistor on a motherboard, or whether we're talking about a baby inferring whether mother is going to feed her or not this evening. That exactly the same principles are in play at every scale, and they all have to be, if you like, married to each other at the different scales, coupled in the right way. So we have this sort of co-evolutionary aspect, but now simply co-evolution at different scales. So one scale contextualizes the scale below, and if quantum information, if quantum mechanics read as a theory of quanta of information can offer that scale-free description of the fundaments of information and reading and writing information, and what it implies for things like the Markov blanket, and in the formulation that I'm referring to here, sort of a holographic screen that would be used in place of the Markov blanket, would play the same role. I think that there's probably is something very pure and very enlightening about reference to quantum mechanics in the light of the questions you're asking. And I would frame it along the lines of the coupling between the inside and the outside across my boundary, across my carefully built, carefully maintained via a generalized homeostasis, all my little boundaries, boundaries within boundaries that make me me. That begs a deep question: how does this coevolution, the circular causality, cross and recross that boundary? So one way of describing that is in terms of this Bayesian belief update and this Bayesian mechanics that you get from the free energy principle, that just describes the statistical coupling between the inside in my head and the outside in the world. That can, that is quintessentially information processing, and it's a kind of process that might support consciousness given certain conditions. But if you were a quantum physicist, you'd just say, oh, that's entanglement. And you have to have entanglement ultimately, because that's the principle of unitarity. So there's no surprise here. You're talking about something that has to happen. So I think that story is very engaging. I'm not sure it's been completely told yet, but that would be, I think, a powerful way to employ the scale-free aspects of quantum mechanics that frees you from the nanoscale, that frees you from having to deal with double slit experiments or looking for quantum-like behavior on little pollen grains on water. If quantum physics has anything useful to offer, it should go right up to the cosmological level. If it's just about quanta of information, discrete bits of a universe, then it should be applicable at the level that the kind of consciousness that we're talking about manifests, which is, clearly the scale and the size of your head and your body and your culture.
No, I think that's beautifully said. I think it's really neat. I'm really happy to hear that you even just a passenger, or that you had been involved in work that involves quantum theory and with this idea, because first of all, the free energy principle is ornate and beautiful and overtly. I'm not an academic in academia, nor am I highly educated. I'm a simple mind. So meeting the free energy principle has been challenging and fun endeavor, and really enlightening endeavor for me. And I've enjoyed, as I've gotten into the work, the Wikipedia page just on it was intriguing when I found it, and it just led me to so many cool, neat ideas. And to find out now that maybe that you also kind of see this quantum element of it being a component, is kind of neat, because a lot of times I'm not able to discuss these things. And so knowing that at least it's not too pseudoscientific to presume that the quantum can be extrapolated to the classical in some way or another is potentially a viable pathway to take when we refer back to consciousness and entanglement, as you said. And I think it's interesting too. What I want to get your thoughts on this, since we are on quantum mechanics here. Information and quantum mechanics, black holes come about when we talk about these things. And you mentioned a hologram or holographic. This is intriguing to me, because back before it was thought that, or I believe it was proposed by Stephen Hawking, that things and matter that fell into black holes essentially was destroyed. It was gone from the universe, which feels just not correct it feels not correct to the field of people who have these observations. And to me, it did seem odd, but I didn't have the mathematical know-how to prove that. So I would never delve or dare to speak on it. But I notice now that there is a reconfiguration in physics that, these objects and these matter that falls into the black hole is not disappearing. It's being repopulated into information that is directly proportional to the surface area of the black hole itself in a 2D form. So to me, that even lends further credence to this idea that quantum field theory and information are intertwined integrally. And at that point, it even brings merit, or not merit, but it brings to my mind something to do with visual perception as well, and the idea of the fermion transformation that occurs with that, where you have photons of light hitting the eye and the retina. If you just take a little, if you just close your eyes a little bit and you're looking at your environment, you can gather the entirety of it almost from just a very closed, partially closed eye. That's just some observation I've made, but to me it seems quite magnificent, because it means that all of this information that's in the environment that's contained within this light is contained within a single photon, or at least contained within a very small portion of the data. And so it almost seems to me like maybe this information and this the visual perception is perceiving it and transforming this information into 3D reality, and that has something to do with how we were talking about the quantum collapsing to the classical through the microtubule. Through that potential theory idea, the microtubules are resonating. They're in a constant dipole state, and when they settle down, or when they become collapsed, they are harmonious with, coherent maybe would be a better word to use in this terminology, coherent with something else, and that resonance and that coherence that occurs between that microtubule or the perception is something akin to this holographic theory, this holographic idea of information and quantum field theory, and then visual perception being something like that as well. Because in a hologram, you have the holographic principle, if I'm understanding it correctly, is the idea that there's all of the information contained within a small portion of it. So just like a cell in a body, it's got the DNA within the nucleus to encode for the machine of the entirety of the phenotype if necessary. And so for some reason, it feels kind of interesting that visual perception. I wanted to ask you, I guess now that we were on to this, whenever you think of visual perception and the holographic idea of information and quantum field theory, all of those things, do you see a commonality between those that kind of resonates with you as well?
Yes, from the point of view of quantum information theory, absolutely. And there are sort of interesting issues that come to mind when you start to drill down on what you mean by information here, because there is information in the information theoretic sense. There's sort of information pertaining to the states or the spins of an ensemble, for example, or a neural network for that matter. And then there's information about something. So I'm talking about the distinction between Shannon information and the kind of information that you might be talking about as a physicist relative to the information that you would be securing from Wikipedia that you just mentioned. So this is information about things. So just focusing on that issue there, which is basically the issue that you were referring to before about, so how do I get the meaning out of sensory data? How is it that I can, even by half closing my eyes, I can still make sense of this minimal amount of data to a remarkable degree that I can now reconstruct exactly the layout of my immediate environments, the objects that are surrounding me, what will happen if I make this move or that move. So you have an incredible amount of information about the outside, about the external states. So I think that is the capacity to do that, I think, is the key aspect of this information processing we were talking about. So from my point of view, then that basically does rest upon having the right kind of living or dynamic blueprint or the right kind of generative model, because that's got all the prior information in it. And having that prior information, having all those constraints in it, means you can make a lot more sense out of a tiny bit of data than you would imagine in the absence of those constraints. So
I see.
That becomes really interesting from a number of different perspectives. I'll just unpack it from a couple, and you can pick up on the one you find most engaging. First of all, I mentioned the word prior, and just to qualify that, in that sense making, in the message passing, and incidentally in the formation of coherence at the level of description of neural dynamics, right down to microtubules. In that sense making, there is the imperative to maximize the marginal likelihood or the model evidence. But what does that mean practically? Well, what it means practically is that you're trying to provide an accurate account of all the sense data, so the photons that have arrived on my retina, in a simpler way as possible. And you do that by having a generative model that mathematically is just basically a specification of how those consequences, sorry, those causes out there produce the sensory consequences. So there's, if you like, in your mind's eye, you've got stuff out in the world, and these are the latent or the hidden causes that are hidden behind the Markov blanket, and then generating sensory consequences, photons on my retina, actively solicited pressure sensations if I palpate my desk, for example. So we never know, because they're hidden behind the Markov blanket, those external causes or latent states of the world. But given the consequences which we do know, because they're on our holographic screen, they're on our Markov blanket, we can reconstruct what must have caused those sensory impressions if we had the right kind of generative model. So, and this is speaking to the sort of, the link between reconstruction of the outside world on the inside, just taking the information that is available on some holographic screen or some sensory part of a Markov blanket. And that job of reconstructing or mapping from consequence to cause. So remember, our sensations are a mapping from cause to consequence. But the making sense of data inside our heads is going the other way. It's going from sensory consequence to the cause. So we want to know what caused this. That's called model inversion, Bayesian model inversion. Technically, it's the difference between making a, well, technically it's written in terms of belief updating from a prior to a posterior. I'm slipping in all these words just to explain why I keep referring to them, because the prior is really important, because that sort of sets the scene to make the most sense during model inversion, during, if you like, identifying or arriving at, through neuronal dynamics, through microtubular coherence, arriving at the best guess in terms of what caused this pattern of information. And sometimes that information can be very, very sparse with the right prior. So we come back again to the importance of DNA and also the dynamic blueprint that is, you can update through experience-dependent learning using exactly the same imperatives in making the most sense of the data. From the point of view of the statistician, that evidence, that model evidence that you're trying to maximize during this model inversion process has two parts. It's got the accuracy and the complexity, which is why I was saying that the job of the brain, or it looks as if a brain that self-organizes itself, must be maximizing model evidence. What that means is it must be trying to provide an accurate explanation for its sensory impressions, that it minimizes the complexity, makes things as simple as possible. That has two important implications. The first one is you have to do this inversion in the simplest way possible, which means you've got to do it in the most efficient way possible, which brings us back to our thermodynamic. So your motherboard has got to run on the least amount of electricity. Furthermore, one way of simplifying things is to coarse grain them. You don't need, if you just need to know whether the light is on and off, you don't need information to the 8th decimal point that it is on. So you need to coarse grain it, 0 or 1, it's on or off. I don't need 1.0065. So that coarse graining is fundamental to maximizing model evidence. There is a description of the belief updating. That is the sense making. That is the inversion, the mapping from consequence to cause, from the holographic screen, the Markov blanket, to the internal representation in our brains. And of course, what we are saying is that the ultimate coarse graining is back to a bit on or off. It's back to the quantum physics. So the ultimate coarse graining is quantum information theory. You can't get simpler than on or off, spin up, spin down. So if you've got the right kind of theory, then that kind of there is a theory of quanta or quantum information theory, then that's going to be exactly the right kind of theory for this ultimately compressed representation of the world. And you see this everywhere, just in terms of language, for example, or the way that we conceive and represent where we are. So, if I say I am in my office or I am in my study, I'm not giving you my GPS coordinates to the 8th decimal place. I'm giving you a categorical semantic quantum of information. And I've tried to tell a story which brings us back to your original question, which is what is the role of quantum mechanics? I think it's in the title, it's on the tin. It's the way that we carve our world up in terms of quantum states of being, which is the simplest necessary to provide an account of our lived world that is exactly compliant with the principles of Bayesian inference or evidence maximization or free energy minimization.
Yeah, there's a myriad of intriguing topics there, or intriguing discussion that you had mentioned there, and I find it all extremely fascinating. And I think within that, like you were saying, there's this generative, like is it the inference that's made against a generative template, and with free energy, a lot of times when I read about it and read about your proposition, your theory of it, it's to minimize surprise. It's to minimize deviation from what we have established to be the normal template for being, the generative inferences that are made. We minimize that element of surprise. And when that generative model is not aligned properly, then that's whenever we see these maladaptive features of mental illnesses, or what we deem, or what is referred to with linguistically as illness. I am not so sure that would be the characterization that I normally would use for those things, but I know linguistically mental illness, and I know that that's part of what I've read a lot of really fascinating work by you that has incorporated that into it. When that generative template doesn't match and the inferences that are made aren't in line with what's being observed, and that applies kind of to the sensory data that we're talking about, perceiving and generating, and the active inferential aspect of this. And going back to the quantum theory idea, is the idea of sensory binding as something that's always fascinated me. And from your view as a neuroscientist, this is something that I've always, and I don't want to just completely deviate too much, but I find it kind of intriguing to me that when you swing a tennis racket or when you hit a baseball, and the sound and the feeling and everything arrive at the same time, but I know for a fact that it can't possibly be getting there at the exact same time. Everything should be all wild. I mean, I should be feeling it a little bit behind seeing it, but what I'm not, there's this binding of sensory data that's occurring, and that almost feels like a coherence of sensory data. It's like all of this input must be coherent in a uniform way, or like some kind of coherence there. And so I just wanted to, I've never really talked with anyone about this, but I wanted to ask you, now that this has come up, the sensory binding element of all of these elements and components, would that imply so much so that sensory data perceived by touch, feeling, sight, and sound must be somewhere? There must be that commonality, and that could be at that quantum level potentially. Would that be possible, you think?
Yep. If I take a liberal interpretation at that quantum level, and by liberal, what I mean is it's a simple categorical explanation for this multimodal and possibly temporarily dispersed set of sensations, then absolutely. So that issue of sensory motor integration and binding, and the binding problem more generally, in terms of binding together various different attributes and attaching them to a single explanation or a single object. For somebody playing tennis, the single object would be me fluently playing tennis, and this accounts for all the visual, the proprioceptive, auditory input. So that feature of our perceptual synthesis and our perception, you get for free through this notion of Bayesian inversion of a generative model. So if I sort of just pictorially sort of put it out, you've got two kinds of sensory input here, say auditory and visual input. And these are being projected onto our holographic screen, they're being projected onto our Markov blanket, they're being picked up by our sensory organs. And then these signals are being passed to the brain, to the neuronal hierarchy or the cortical hierarchy, and it's trying to make sense of these signals. But remember, this is a mapping from sensory consequence back to cause, so it's an inverse mapping. But the way it's actually done is by generating predictions from a hypothesis, and then, as you rightly comment, generating a surprise signal or a prediction error, and then using the surprise to get a better explanation. So what we're actually perceiving is not the sensations all in their own modalities at the lower level of the hierarchy. It's the best explanation at the top that is, in a top-down way, explaining all of these disparate and possibly temporarily dislocated sensations. So the sensation can be very disintegrated, but its explanation is necessarily bound because you've got this divergent top-down explanation for what's going on. And in the sense that the source of that divergent explanation is the quantum of the state that currently best explains everything that is going on, that entails within it both the coarse graining and the coherence that it establishes all the way down the hierarchy. Yes, in that liberal interpretation, it is a quantum-like phenomena. Yes,
that's intriguing. It's fascinating too, and I think that it's critical that free energy. I mean, I do not understand my being as simple-minded as I am in academics and everything. I don't make too much sense of mathematics that well when it comes to calculus, and when it comes to advanced mathematics, it's not my forte, so to speak. It's not like I had advanced training in mathematics, and so of course the free energy mathematics is beautiful, but I fail to understand it just from that level. However, I understand the active inferential implications of the surprise and the reference of the surprise back to what our generative template, and I understand it metaphorically and allegorically in a way that allows me to couple together this whole idea. It's almost like, to me, like it's a critical middle ground, or not middle ground, it's a critical holistic binding. This free energy, the idea of free energy that you propose, is critical to providing the sensory data binding and then making sense of it in a recursive cyclical pattern that meshes with that, and to hear that you are pursuing or have pursued or are interested in formulating hypotheses further that involve quantum mechanics is quite intriguing to me. I just find it, and the holographic element, going back to that, the holographic element of the universe, the holographic universe idea and the theory. And I had heard a discussion between several physicists, a TED Talk kind of a situation, but with multiple participants. And it was referencing the evolution of theoretical physics into into basically classical physics, and having to override what was so hardwired into physics. I mean, Stephen Hawking, what they were basically saying, these gentlemen, I believe it was Brian Greene was one of the members potentially, but their discussion was how it kind of feels to me like it was a deviation from the generative template of physics so much that it was impossible for it to be accepted. When Stephen Hawking, basically they said this, and I'm quoting them, of course, when Stephen Hawking said so, it was so. And so to go backwards from that was almost impossible to do, to reframe this idea of information and it not disappearing, and to say that it could repopulate in proportion to the surface area of the black hole. That whole idea gives credence to the holographic theory of information for sure, but it definitely is unique that it takes a long time to override generative templates, or not but how we like this active inference. To me, it's so fascinating because we have to regenerate, and it's almost comparable to thinking of the brain once again as a circuit. And when sometimes I like to think of parallel electrical circuits, because that's what I did for a long time for a living, was electrical design of low voltage electrical design, CAD design. And so I think about circuits and a lot when I think about things. And so parallel circuits and neurogenesis within the brain, these multiple pathways to get to the same outcome, dismantled for me the strict type physicalist view of this area of the brain activates, and thus we have this emotional state produced. That kind of dismantled a little bit of the physicalist, strict physical view of mind and matter, and began to progress me into panpsychic viewpoints and things of that nature. But it seems like, yeah, the deviate. I kind of forgot where I was going with that point, but I just find it interesting, the active inference and the generative template, and using that once it's embedded, and once we've embodied a very precise idea of how things should be, and a massive surprise occurs, and we see things that might be representative of anxiety or mental illnesses. But then when we see repair and I'm just anecdotally explaining this, of course, and it applies to me personally because I used to suffer from what I was diagnosed or told was generalized anxiety, and was medicated for it, and desired no longer to be on that medication because of I wanted to personally not be on it, and I was able to successfully do that painstakingly, so to say, however, and in doing so, I noticed that as I'm not deviating, I'm not going into the fate, but as I engaged in practices that were more contemplative and engaged in practices that helped me combat that anxiety, it almost seemed like, when I started looking, I was like, well, you know what? I like to explain things scientifically. I'm not going to accept that this contemplative practice possibly did anything, because it's not scientific to me. So I started to look into contemplative practices and the science behind them to see did I do something to where I reframed my generative template versus the world, and so now my anxiety levels are lowered. That's the comparison I'm making here as in our dialogue for the first time, and thinking in circuitry. And so maybe in a parallel electrical circuit, you've got multiple routes. So if you sever one part of the circuit, you can have lights further down the circuit still active. I was thinking maybe in this dynamic model of the brain that's a little bit more dynamic rather than static, neurogenesis almost acts like a parallel electrical circuit by which we can reconfigure that generative template, therefore perform more accurate active inferential perceptions of our sensory data. And I wanted to ask you, as a neuroscientist, on this perspective, do you think that since I was able to, I suffered from the terrible anxiety, and then I was able to get off of it over time, not about how it happened, but more so, do you see that, because I know for a fact, subjectively, that the side effects of the anxiety dissipated and dismantled over time. Do you think that the dynamic model of the brain, so to speak, where it's more network, more integrated, not so specific to the temporal, parietal, occipital lobe, but more of a networked, ever evolving thing, that fitting in with the active inference and the free energy idea could be a mechanism by which we heal, not heal, but by which we come to perceive the world more accurately or more generally?
Yes, I do. And I think the metaphor of a circuit is absolutely right there. That is just parallel distributed processing. And the key thing that you're bringing into the mix here is the dynamic rewiring or tuning of the connections and the wires. I mean, a transistor will do that in an on and off kind of way, or you might put some sort of rheostats in. But the key thing is that these wiring diagrams are tunable, and not only over hours, weeks, and months in the sense of experience-dependent plasticity, so growing new wires or removing redundant wires, but they're also controllable over milliseconds. So there's a routing, if you like, of the messaging on the circuit board in these hierarchical brain circuits that itself has to be predicted. And I'm saying that because it is likely that the resolution of your generalized anxiety disorder with contemplative practices and a change in the way that you handle the situation rests upon a resetting of the prediction of the various weights or gains or gating that you apply to particular wires on the circuit board. So just to connect that to what you also mentioned, which is understanding free energy minimization as surprise minimization. I think that's absolutely right. I've been selling free energy as negative model evidence, but it's also, you can think of free energy as prediction error. And prediction error just scores the surprise. So if I go around and every time I predict something, I get a massive prediction error, I'm going to be constantly surprised. And if I'm constantly surprised, I'm going to be pretty anxious. And if I can't resolve that surprise, if it's irreducible prediction error, no matter what I do, I can't explain it by changing my mind, do my belief updating, my information processing, nor can I avoid or find some contrary evidence or some other kind of sensory data that is more predictable. So it's irreducible surprise everywhere you look. So this would be a state of high free energy on average over time, and almost invariably these are associated with feelings of angst or anxiety. The average surprise, expected surprise, is uncertainty. So what we're talking about now is irreducible uncertainty. So everything has a high prediction error. I expect there to be high prediction error, whatever I do. So these are situations that normally would produce angst and anxiety. I should just say, from my point of view, these are the kinds of situations that I use the hypothesis I am anxious to explain. So the very notion of being anxious is actually a gift. It's a part of self-modeling, and the fact you can recognize you're anxious and tell yourself I am anxious is remarkable. And should be sort of valued, because if you were alexithymic or you're a lower sort of creature, you may be in a state of high anxiety and just never know it, and never be able to do anything about it. But of course, you can do something about it if you know that you're in a state of anxiety or you have irreducible prediction errors. And normally that's that whatever you do about it, either changing your mind or adopting another approach in terms of your plans, or an alternative hypothesis in terms of your explanations, then things will no longer be surprising, because you can explain things again and your prediction error goes away and the anxiety goes away. So what would happen if it didn't go away? And that's obviously what you contended with. So then really that requires a possible re-prediction and building a new kind of blueprint, not for what's going on, but for how to do this gating of the message passing and the wires. Psychologically, this would be like attention. So if I want to with my belief updating to be informed by these prediction errors in this sensory modality, then I'm going to upweight those. I'm going to attend to those by boosting those wires. But I have to predict that. I have to predict I am going to attend to this before I can do that. So I have to learn that this has precise information, and that precise information has to be realized in the message passing by by activating those transistors and letting that information travel down the wires. So that coordination, that attentional selection, or indeed attenuation of certain kinds of information, is itself a part of the blueprint, a part of the generative model, and has to be deployed in a skilled way by a good generative model. So most people would argue that contemplative practices, things like meditation or just taking care of yourself or thinking about things, mindfulness, most of these are all about skilling you in deploying your attention that just is selecting the right sources of surprise or prediction errors and ignoring those that don't matter. So that's why I imagine you were able to take yourself off the medication. Interestingly, I can guarantee that the medication you were given is a kind of medication that reduces the excitability of the cells reporting the surprise or the prediction errors. In fact, all psychiatric medication is of this kind. As interestingly, that's exactly how anesthetics work as well, but in a much more sort of heavy-handed and broad way. But certainly most psychoactive drugs act by decreasing the excitability of particular cells. The actual cells are the ones you actually mentioned earlier on in relation to the Orc hypothesis, pyramidal cells in certain parts of the brain. And these basically quieten down the prediction errors of surprise broadcasting. So what you have done is learned to do that volitionally through your own distributed processing by becoming more skilled in deploying your what's called attentional set in psychology. So another word for all of these meditation-like practices and mindfulness approaches are those that engage attentional sets and produce particular sorts of internal attention. And what that is really saying is you're building a generative model, you're learning a generative model that allows you to activate or not all the right transistors lower down in the hierarchy, and thereby minimize your expected surprise and resolve your uncertainty and free energy.
Beautifully said. Excellent. I have so many points in there that I find so fascinating too, because of how related that is to this meta level of processing that we were talking about earlier with the evolution of selfhood. Whenever you're able to think about thinking, you are inevitably employing a aspect of cognition that is high level and almost integrally related in referencing self and acknowledgement of self. And the inverse of that which I'm once again not too well versed in any of this academically, but depersonalization or disassociation from one's personality would almost seem to be the inverse of that, to where you lose that meta cognitive ability to evaluate one's self's thoughts. And so that was a conclusion that I had come to as well, much more simplistic language. So you just put it in language that really resonates with what I feel and subjectively. And it was, my idea was, okay, I have a thought. And when I kept thinking, well, I must be generating this anxiety from identification with thought or over identification with thought, but it might have been just the incorrect template by which I was perceiving and comparing and such. And so I was thinking, what mediates action is what basically between thought and my actions, what was happening there that mediated the action to occur? Because I have lots of thoughts, and so only some of them turn into action. And so what is it? I was like, is it an emotion? Is there an emotion or a feeling that I'm having that then I act upon that feeling more than other feelings, and that and such and such. And so the way you just described that kind of portrays to me more linguistically a lot more poetically than I could to myself, and also explains to me a little better what was going on. But I find it intriguing that, yeah, that metacognitive level of self-evaluation is attentional. And it's interesting because you were talking about, it's like distinguishing what not to pay attention to. It's like, because whenever right now when I'm sitting in a room and I'm talking to you, and what I find pertinent to my attentive consciousness is this dialogue and your words and active listening. And I see there's a lot of other things that I could direct my attention towards, but I narrow it down to this particular part of it. And so I find that interesting. it's almost like a salient. I think this is a quote from someone else. John Vervaeke's a professor that I listen to on YouTube a lot, and he's a very eloquent speaker, and he speaks on something that he refers to as the salience landscape, which is like what you find salient in your landscape, and it's kind of Platonic, Neoplatonic in its philosophical origins, but it's the idea of just what you said. It's narrowing down that attentional landscape and making things salient to you in your landscape that were different than before. But that, I always wondered, like, well, what is mediating it? Well, it's free energy, or it seemed to be the active inferential updating of that template. And that it's what do we find salient in your landscape? Whenever somebody has I was talking to Dr. Andrew Newberg is his name, and he writes a book on neurotheology and the science of enlightenment and things of that nature, and just asking him about these things and studying the brain from the third person angle whenever someone has these mystical experiences or psychedelic experiences, and then there's a rapid change in their cognition. And then I thought maybe that's related to the salient landscape. Maybe now they're perceiving in the world more differently than they were before. They're finding things intriguing and attentive more than they were before, differently. And that seems related to attention. And so when we talk about attention, that seems extremely important in our consciousness. And it seems almost like a hyper-focused aspect of our consciousness. Is that kind of an accurate portrayal of attention? And is there, in your mind, a lot of significance to our attention?
No, I think I agree entirely with everything you've said there, and yes, absolutely. So there are people who think that emotional constructs like, I'm embarrassed, I'm in love, I'm anxious, I've got depression, all of these are just hypotheses that if you can correctly recognize your emotional state, your feeling state, then you can deploy the right kind of attention and grease the right pathways, turn on the right transistors to, as you very properly note, not just increase the precision or of certain messages from more salient parts of your sensorium, but also attenuate. I'll give you an example in a second. So the purpose of having these very high level self-referential metacognitive like hypotheses as part of your living blueprint, your generative model, your deep generative model, simply is to predict the right precision or salience that contextualizes the message passing lower in the hierarchy. There are people who call this mental action. So it's not overt action, not moving your muscles, but you are basically changing that rheostat, or you're switching in that circuit and switching out that circuit, attenuating this and activating that. That has to be predicted and coordinated and learned, and this is just the deployment of attention. So in that sense, I think you're absolutely right. And if you subscribe to this notion that this dynamic setting of the message passing through fast fluctuations in message passing mediated by regulating or modulating neuronal excitability is mental action, then you could actually say that certain kinds of generative models that can support this kind of mental action are now getting very close to what you mean by consciousness. And notice what you've done. You've tied together the ability to deploy attentional set, attending to things, with mental action, with the kind of information processing that is the hard problem would worry about. So I think that's an important way of looking at it. This notion of attention underwriting the contextualization, to come back to your notion of context, the contextualization of the information processing, of the belief updating, that rests upon greasing the right pathways, switching on, selecting the right wires, the right transistors, the right neuronal populations, then I think you're now in a much stronger position and has to talk about consciousness of that underwrites experience of self and self-awareness and possibly even qualitative experience. I said I'd come back to the importance of sensory attenuation because I think That's so important, and people, I don't think, realize that. They all think about, oh, I've got to respond to what's salient. Most 99% of what we have to do is to know what to ignore. So, this is often brought to the fore in the treatment of chronic pain, that it's very easy if you now conceive of pain as one of these hypotheses, explanations for everything that's happening to me, all my sensations, as opposed to it is something that is sparked or induced by some noxious sensation, then you can see immediately why sometimes certain signals will be misinterpreted as pain if you can't attenuate them. So say I've eaten too much and I get certain signals from my tummy, interoceptive signals, gustatory signals to my sensory apparatus, low level in the hierarchy. And if I, a priori, I have learned that the simplest explanation is pain, then, and I cannot attenuate or attend away from these sensations, then I will explain this, oh, I am in pain. If on the other hand, I interpret it, oh, I've just eaten, I can ignore those prediction error signals. They have no newsworthy information. I already knew I was going to get that kind of pain. I would ignore them, and I would decrease. I would engage the right transistors, and I would attenuate those signals. Nothing to explain, and I'm not in pain. And we can actually invoke that just by rubbing our tummy, because rubbing our tummy automatically induces sensory attenuation. So one explanation for making pain go away when we rub our tummy is that we are actually causing those sensations because we're doing the rubbing. And if we're doing the rubbing, they become very predictable and therefore unnewsworthy. If they're unnewsworthy, they have no salience. If they have no salience, I can attenuate them. And therefore, I don't have to explain them, and I don't have to worry about being in pain anymore. So that notion of actively, either through covert mental action by deploying attention, or overtly by using sensory attenuation by moving, getting control over what is not salient is absolutely crucial, I think. And I suspect is what underwrote your ability to get off the anxiolytics when you had generalized anxiety disorder.
Once again, yeah, beautifully said, and I identify subjectively with that when we're talking about my experience. And as you describe your opinion on how you presume my experience went, I subjectively identify with that explanation extremely well. I mean, in fact, almost precisely with the way you describe it. And yes, it was benzodiazepine, so they were doing the function that you were describing. They were depressing these signals, so that was accurate. And additionally, one of the things that you had said about pain and attribution of self, that in contemplative practices, sometimes I noticed that there's the benefit. Of course, they're practitioners of these things, and the people who publish data on this and promote these practices generally try to lower the sense of self, or there's a goal in the end to dissolve or not dissolve, but be able to transcend, in vogue terminology used to describe the state of oneness. However that may be linguistically conveyed, I guess transcending would be the way they would use it. But the idea of, like you had said, misinterpretation of signals, it's almost like the generation of the sense of self is like multiple senses of self potentially that come about when we're talking psychology. And once again, I'm not any of these things in academic framework. However, in my subjective experience, pain, like you had said, attributed to yourself, it's like, okay, my leg hurts, so now I'm going to tell my head also. It's like I am talking about myself. There's like two selves there, and so these contemplative practices try to dissolve the double attribution of these signals, almost, where it's saying, well, I myself am in pain, or I can't stand myself. Well, who's I and who's myself, and why is there two of me? And so it's the lowering of this threshold for selfhood to identify so stoically with it receiving its inputs. And so what you say about pain and stuff, contemplative practices, all of that merges poetically together in your description, and to me subjectively to verify that. Obviously academically it's extremely well said, but subjectively it's cohering with me super well. I really find that intriguing. And additionally, it's like you said, to compound further onto that interpretation of these signals, one of the philosophers of mind that I subscribe to significantly, and Sam Harris, he writes on this, or talks on some of these topics, one of them being anxieties particularly, and he talks about how technically there's anxiety that produces this uncomfortability, and then there's the same emotion or the same feeling is what we feel before we voluntarily get on a roller coaster or go bungee jumping. It's like we're reframing the same emotion, and it kind of pays homage or pays credence to what you just said about the attribution and the interpretation and the active inferential nature of it. It all ties together that, yes, you are feeling the same emotion. Why am I'm paying money to be put into an anxious state, but yet I am dreading being in an anxious state before I go into an interview with a job or something of that nature. Interesting to me that all fits together, and the duplication of self and the creation of multiple selves psychologically. Maybe they refer to it as ego, or there's all kinds of ways of probably referencing the second self that we create, or whenever, like I had said, like I can't stand myself or something. I've kind of find that statement enigmatic, because why can't I stand himself, or where is that duality of selfhood, and why does it exist? But we've talked about that in this discussion already, but I just wanted to acknowledge it and also explain to you that, yes, subjectively that makes a lot of sense to me, that it's free energy and it's active inference that's mediating that almost. I would that in my interpretation.
I think you'd enjoy speaking to Mark Soames, who is one of the world's experts on Freudian analysis, and I'm mindful of things like ego dissolution, for example, would be, but also probably, although he's also an expert on Freud, he's one of the champions of the sort of neuropsychoanalysis movement, which tries to understand the mechanics of sense making and how it goes wrong in various sort of in neuropsychology and neuropsychiatric conditions. But he's just written a book called The Hidden Spring, where he talks about felt uncertainty. So he thinks that all feeling of a conscious sort is all about noticing this uncertainty, this the thing that underwrites and grabs our attention or calls for this mental action. So I think you'd enjoy talking to him. The other person is Robert Carhart Harris, who's an expert in psychedelics, because exactly the same story from the point of view of modulating neuronal excitability pharmacologically can be unpacked in terms of the utility of psychedelics, in terms of this sort of what he would call sort of flattening the prize, so that you are now you're destroying deliberately attention to selfhood and high levels of hierarchical inference, and focusing on the sensorium, so that you are attenuated in terms of attenuating the very high level precision, whereas because you are becoming skilled at attending to the sensorium, say the breathing. So this pattern of retuning and rebalancing the message passing with neural excitability is the kind of pattern that is reproduced by the careful administration of certain 5-HT2A drugs like psilocybin and another psychedelic drugs. So there's another fascinating story which links psychedelics and the way that we treat our sensorium when in a psychedelic state, and how that speaks to a sense of self. And you mentioned derealization, depersonalization before. There's some really interesting links between the pharmacology, the sense making, and meditation, and indeed psychiatry there, which would another 2 hours of conversation.
Yeah, absolutely. No, you're exactly right. And I find that interesting too. Yeah, the dissolution of ego, and the tie together of contemplative practices and psychedelics. There's a referential relationship there a lot. When people talk on psychedelics and then talk on meditation and contemplation, those merge. I mean, any conversation or dialogue that I end up in listening to on YouTube or hearing about, or even discussing myself with others, evolves, if it's contemplative in nature. The conversational topical nature of it is about contemplative practices or something. like it brings in the ego, brings in psychedelics, brings in Freud, and then Carl Jung, and so these concepts generally are tied together, like you said, and they all find a binding coherence when it gets to the sense of self, and selfhood is what really brings them all together. If you speak on sense of self, you inevitably speak on sense of other, and then on sense of internal self, like the voice in your head, and the lowering of that voice, or the ability to control it, acknowledge it, understand that you are not a subject as a passenger within your brain, secondary to your feelings. So it's like you were saying, the 4E embodied cognition kind of thing. It's if you have pain in your knee, you don't need, it doesn't necessarily need to be reinterpreted again in the brain and attributed back to me, where I'm in pain, and constantly feeding back into that loop of I'm in pain. So because I'm in pain and I hate that I'm in pain, so I'm in pain. You're telling yourself that consistent cyclical internal dialogue with your own fabricated sense of self to a certain extent. And that psychedelics do seem to dissolve and create that. It's like almost some people I've heard describe it as a cheat code to meditative contemplative states of samadhi or something like that. But where you can get right to that, break the barrier down of self and other, and feel the oneness that's necessary to understand this concept objectively, which seems to be integral to describing it, because it's so hard to put language to those experiences. And so I see what you mean, and I appreciate you mentioning those couple of gentlemen, because I would love to read their work, and most certainly am interested in furthering my understanding of self psychologically, for sure. So I will certainly do that. And I appreciate this conversation, and I really appreciate this dialogue, and I really appreciate all of your time that we've had spent. And I know it's been a couple hours, so I guess I'll bring it to a conclusion now, but to free you up. But I wanted to just say how much it means to me that you came on here and spoke with me, and how fascinating I found this dialogue, and just how truly much I appreciate your time, and the time you spent with me in this interview just means a lot to me. And I hope to be able to further my understanding of your work through this, and my own understanding of consciousness as I move forward. And so I just wanted to reiterate that your work has impacted me significantly. It's helped me bind together a lot of topics that were floating around in my mind that I couldn't find a commonality to tether them together with. And for that, I am grateful for that.
Well, thank you for those kind comments. It's been it's been great talking to you. All your questions you seem to answer yourself, so you've clearly done a lot of reading and have wisdom, and clearly an intuitive grasp of the maths and the physics, even if you haven't actually got the qualifications. So it's been great talking to you. Thank you very much for entertaining me.
Yes, no, absolutely. Bi-directional for sure in that. I am very, very grateful for it. And so thank you very much. And I will hopefully talk to you again in sometime in the future, but I will look forward to your work. And thank you once again. Have a great rest of the day.
And you. Take care.
Take care. Bye.